Hey everyone, welcome back to the Latent Space podcast, our first recording of 2025. I'm Alessio, partner and CTO at Decibel Partners, and I'm joined by my co-host Swix, founder of Small AI.
Hey, and today we are here with a special double guest episode with Amir. Oh my God, I don't know your last Hagiat.
Close enough. That is good. As far as first tries go, that's really good.
And Yining Zhang from Baseten. Welcome.
Thank you.
Thank you.
Amir, we've met before. You're co-founder of Baseten, which is one of the leading sort of LLM inference platforms. I don't know what do you consider yourself?
That sounds fine.
And Yining, you are lead software engineer on the model performance team, and you guys recently shipped DeepSeek V3 as one of the many models that you do host. You also are very involved on SGLang, and that was actually one of the reasons we're discussing an episode with you even before DeepSeek V3 dropped as a Christmas present to everybody. So we can take this a number of directions, but I think one thing we wanted to just get off the bat on was to start with DeepSeek and then we'll work our way back to SGLang. But DeepSeek is more recent. Why are people so interested? What's the history of DeepSeek in general from your perspective?
Yeah, because DeepSeek V3 I think is currently considered the leading open source LLMs based on the benchmark results and the chat area results. And it's so big, it's 671 billion parameter MoE. And I think it's a game changer for the open source AI. So everyone is interested in this model. Yeah.
One of the interesting things is they are bootstrapped, very private, small lab. Like they have a fewer resources than others. But it's also interesting that it's just open weights. For some reason, the Chinese labs are much better than the American labs at sharing open weights, and that's obviously beneficial for Baseten. It is in your incentive to serve these models at all times. What are sort of the unique challenges that you face, offering something this large?
Yeah, I think because the model is very large, and if we use something like use H100, we cannot serve this model because even we use the H100 8 cards, it should be 640 gigabytes memory. The DeepSeek V3 model, it has 671 billion weights. So even use the FP8 precision, you need, I think, 671 gigabytes for the weights. And you also need extra memory for the KV cache. So it's not possible to run that on H100. That's why we choose H200 to run that model, or use multi-node to run that model. Yeah, it's very challenging. And I think another one is that DeepSeek V3, the weights it released was the FP8 precision. So if you want to run it, you should support that kernel. Because I think the default is the BF16 and even larger. But if you want to run the FP8, you need to support the quantization. So I think currently even the TenCent RTIM doesn't support the FP8. So if we want to implement that feature, we should do some feature development for that. The last challenging part is that, if you want to do some debugging or some performance benchmarking, it's very hard. Why? Because the model is so large and the loading time is so long. Yeah, so it makes it more complicated for the developer to do some debug.
Is it complicated or just slow? I mean, you've just only mentioned loading time, but
Yeah, loading time is slow. Yeah, you're right.
It's not complicated. It's just just go for more coffee.
Oh, okay.
Can you maybe just give people a quick rundown of all the models you support on Baseten, how it compares just on size, just to, people here 671 gigabytes, but is that a lot more than other models? And then you mentioned the BF16, FP8. What's kind of the usual that you see? And do you see any variation based on model size or anything like that?
I think at Baseten, something like Llama 70B is more common. I think Llama 3 has released the 405 billion weights, but I think there are just a few users use that. So before the DeepSeek V3, I think we haven't encountered that issue for that so large weights. I think DeepSeek V3 is the first one so big model that we should use H200 or use H100 multi-nodes.
And was that because of performance, or why did people not use the 405B Llama? I think what I hear from people is like, the performance gains of like the 405B at inference times are like not worth it, so the 70B is kind of the sweet spot. Who are the people that use V3? Are people that were using maybe the Llama 70B model and just want better performance? Are people that are just experimenting? I think that's kind of the question that people always have. There's always a lot of excitement around open source models, but then maybe the question is like, what are they really good for?
I can answer this just observationally. The interest that we have seen, and some of this is running in production, some of it is just at the interest level, is generally not coming from folks who are trying to upgrade from a certain open source model to DeepSeek V3. We're seeing it, generally speaking, from folks who are coming from Claude and are doing so either because, and I'm going to give you a list of reasons, and generally the reasons are a certain combination of these. In no particular order, either it is they're being rate limited, or the price is too high, or they have certain latency requirements or time to first token requirements for their use case that Claude cannot hit, or they want to have full control over the model as opposed to running it behind an API where the model underneath them can potentially change, and a couple other reasons. But generally, it's a combination of those.
You mentioned the speed and some of these things. Do customers want to change the hardware also? Like, you're referring to H200 is kind of like the default thing. Like, do people come to you and it's like, hey, I'd rather use a smaller system and kind of worse performance? Or how do you work with customers on that?
Generally, people come with certain requirements around the latency, the throughput, the cost. Generally, they're not coming in saying, I want this particular GPU SKU. At least like as we go up market and we're talking to, foundation model companies, for instance, the things that are top of mind for them are those requirements, not a particular GPU SKU. We're doing the different GPU SKUs not because we want to, offer, oh, look, we have H200s, look at us. We have MIG'd the H100s, look at us. It's not that. It's really because those are the tools to achieve a certain kind of time to first token for certain types of models, or certain kind of throughput and scale, or a certain kind of price per million token or what have you, per million images, depending on the modality. And that's the reason that, we're talking GPU SKUs.
I wanted to pick up a little bit on this FP8 thing. It seems like, I think Noam Shazir started talking about sort of training natively quantized, and I think that's what DeepSeek seems to have done, at least they said in their paper. Is this a trend? Like, is the community settling on one form, one sort of numeric that everyone knows about? Tell us more about what you're seeing here in terms of like the training trends, the sort of model trends, and I think a lot of companies as well, like together, they'll also release like quantized versions of the Llama models, right? Like for like turbo or light inference, or, like just based on different levels of speed. Like, do you do anything there in terms of quantizing the models that you serve?
I'll let Yineng answer the sort of patterns around, using FP8 in training. But I want to draw one distinction that I think gets to the latter part of your question, Sean, which is that unlike companies like, you mentioned Together or, Fireworks or Replicate, Baseten doesn't provide a shared inference endpoint for the popular open source models. That is a product that we don't have on purpose. Those work really well. The shared inference endpoints for open source models work really well for situations where the user is saying, hey, let me just call a certain popular model behind an API, pay by the token. That is not our average customer or the median customer. Our customers generally have their own custom models, very custom workflows, strict requirements around latency and time to first token, and can't deal with noisy neighbor problems that like, oh, the API is slow because some other customer has been calling it a lot. Other requirements around infrastructure flexibility, around regions, for latency reasons, for compliance reasons. That's the side of the inference market that we capture. And at Baseten, when you deploy a model, whether it's your own custom weights or an open source model, you get dedicated inference, dedicated resources, dedicated inference. And so when it comes to the quantization question, where it matters is that we would never quantize the model behind the user's back and say, look at us, there's a faster Llama 70B that has been somehow quantized to be faster and cheaper. Our customers are coming to us with those requirements that I mentioned, but in particular, when it comes to model quality, they have strict requirements. They would not be okay with us touching the weights, if you will. We have done things like speculative decoding with a couple of different ways, but all of those things, those methods guarantee the output is unchanged, as opposed to quantization. So when it comes to quantization, we have built tooling that allows our users to quantize their models. For the ones that we're working more hands-on through our forward deployed engineering team, we're working with them on evals as well to ensure that the quantized models are meeting their requirements. However, this is all very much in conjunction with the engineers that are customers, as opposed to us doing it behind the scenes.
FP8 training is very interesting, and I think the DeepSeek team is the first one to use FP8 training for the large model. I think before that, maybe Ling.ai, 01.ai, they use the E-Lightning. They use the FP8 training. And the others, I think most of them use the BF16 training. And it's the game changer. And for us, because the FP8 kernel should be implemented inference, it uses the block-wise FP8. And currently, even you use something like CUDA or cuBLAS, you cannot support that. So you should use something like Triton to implement the kernel, or you should use something like Catalyst to implement that kernel. So I think that's the challenging part.
My theory is that this will pick up in terms of the models that people release. Like increasingly, it'll not be BF16. There was a bit of quantization. I was trying to look for the paper while you were speaking, but I couldn't find it. But there's sort of this like ablation of quantizations paper that was out last year that showed that there is benefits of quantizing and sort of natively training all the way until like 6-bit, and then like even smaller than that might be going too far. Yeah, I'm not sure if you know what paper I'm talking about, but yeah, there's an interesting trend for sure.
Yeah, I think even they use the FP8 quantization, the benchmark result is very good, such as something like GSM8K. The score is nearly 94.6. It's so high, I think it's higher than every other open source LLM, even the Llama 405 billion.
So I'm going to move on a little bit in terms of like one other notable detail, and then we don't have to speak too much about DeepSeek because obviously we don't know that much unless we work on the team. But like another trend that they have is the fine-grained MoE. I think that there is this question about whether or not MoEs will be more of a thing. Basically, like this time last year, Mixtral was sort of kicking off a bit of a MoE trend with the 8x7B, 8x22B. And then the rest of the year, no MoEs, basically. So is this like discovery of fine-grained MoEs going to be a relevant trend for this year?
Yeah, I think so. Because as far as I know, some companies such as Baidu or Baidu Dance, their internal, the dominant LLM, they use the MoE architecture. And their weights, I think, is similar to the DeepSeek MoE model. So I think at this new year, the MoE inference optimization will be very essential and so important.
At the same time, like why hasn't the big labs done? Why haven't the big labs done it, right? Like I think, well, Llama 405B is dense. I think Grok is also a dense model. You can correct me if I'm wrong. And yeah, it's just a weird counter trend. I think this time last year I was like kind of writing my recap and I was like, all right, MoEs like seem like they're going to be trending, and then they did not trend. Anyway, it's just a note that I would flag out there. But I generally agree. Like it seems like fine-grained MoE is working out, and I would definitely want to see more people adopting it. I went to Jeff Dean's session at Europe's, and he also mentioned as well that I think Gemini 1.5 Pro is an MoE, which I don't think we knew before that.
Yeah. So the reason why Llama open sourced the MoE model, because I think they tried to train an MoE model, but they failed. So that's why they didn't open source MoE model for Llama series.
What are the causes of failure? Like, why do MoEs fail? Like, I think this is another thing that people are talking about, right? Like the failures of 3.5 Opus, the failures of GPT-5. Like, it's a thing that people are sort of rumoring.
Yeah, because if you want to train a model for the training stuff, you need to some benchmark or some score. But for the MoE model, the benchmark score is even lower than the dense model. So in that way, or in that case, they think the MoE model is worse than the dense model. So they didn't release that MoE model.
Okay, well then one more thing, I guess, maybe more commercially relevant. DeepSeek's API pricing is very competitive. How do you decide pricing in this kind of landscape with open models?
Yeah, so it goes back to the use cases that we serve, and again going back to the fact that we don't have shared inference endpoints for the different models, and so our pricing is never per token. Customers, like I said, generally come with their own custom models or open source models, but with strict requirements around certain things, latency and time to first token requirements, or security and compliance requirements, or particular scale that they're looking for without running into noisy neighbor problems, things like that. And the way that we price has always been based on consumption of resources. And that takes one of two shapes. One is the shape where things are running inside of our infrastructure. And we're running, by the way, on top of multiple different public clouds, many different regions within those. Then we charge them based on the hardware, the resources that they're using. The second shape that it takes is that our customer brings their own cloud. And we're seeing this more and more, where a customer has big committed resources inside of their AWS VPC or GCP or what have you. And in that world, we also have a consumption model. Of course, the price is very different because they're using their own resources, but we are managing those resources for them. An example of that we're seeing more recently is the fact that we've had to build multi-cloud capabilities for us so that we can have a single model horizontally replicate across different regions and even different clouds. And more and more as we go up market, our customers have their own cloud commits. They are also multi-cloud in order to be able to get good prices and good capacity. And it's unreasonable to expect every one of them to build the same multi-cloud capabilities that we have built. And so then they take advantage of what we have built and use all of the different cloud resources that they have as a whole holistic unit and have their models at inference time horizontally scale across those, and even optionally overflow to our cloud when they start running out of committed resources. All of that has a consumption pricing model to it.
Can we talk about what it takes to actually run your service? So we had episodes with, replicate model, fireworks. We always like to ask this question. Obviously, since you're not the model maker, all the secret sauce is in how you actually run the model. I know you also have Trust, which is your more developer-led SDK. Can you maybe quickly run people through how do you go from taking the DeepSeek V3 weights to actually run it? What goes on behind the scenes? And then we can talk about SGLang in depth a little more.
Yeah, totally. So we have, like you said, we have Trust, which is our open source model packaging and deployment library. Trust works with different frameworks underneath it. It has very native and deep support for TensorRT-LLM. Somewhat as an accident of history, we happened to have access to TRT-LLM before it was announced, contributed back to it, and we still do, pushed it to its limits, and had to go beyond it in certain areas as well. So, for example, if you know the Triton inference server, we've had to build our own version of that for performance and reliability reasons. But we invested in it heavily because it tended to be, for the use cases that we were seeing from our customers, it tended to be the best framework to handle the latency and throughput requirements that we were seeing. In particular, when it comes to the kernels that they come with, I'm yet to see folks do better than what NVIDIA can do when it comes to CUDA kernels. However, trust is not tied to TensorRT-LLM. For example, for the DeepSeek example that you mentioned, is working with SGLang, which is really cool to see. And we will be investing more and more in SGLang, especially as the developer experience is just so much better than TensorRT-LLM. We've built a lot around TensorRT-LLM, productized them too, to make it easier to work with, but still SGLang has been a joy to work with. Another trend that is really promising, and I learned this from the SGLang folks, is that the TensorRT-LLM folks have promised to modularize a lot of TRT-LLM so that other frameworks like SGLang can grab certain parts of it and build on top of it. And so as a user, you don't have to go all in on one framework versus another. You can really pick and choose based on the requirements that you have. And that's really been our approach as well. We have customers on Baseten that are using TensorRT-LLM. We have ones that are using VLM. We have a growing number that are using SGLang too. It's not about really tying yourself to one versus another. It's about using the best of the bunch, depending on the requirements of the customer and for their inference workloads.
How did you think about designing the framework? So Replicate, also a cog, which was kind of more tied to Docker. What were maybe some of the design decisions that you had, and how do you think that's changing, especially as the models change and like the runtimes change?
Yeah, totally. So we started Trust, like 4 or 5 years ago. And at the time, the sort of principle that we had in mind was, let's make sure that easy things are easy, but hard things are possible. And so an example of easy things being easy is that, think of it as a very simple, you have a model. What do you need to do to serve it? Well, you need to load it up, and then you need to write the code for the inference path. And, Trust actually had, hooks for these two things. And so you could just, write two functions and voila, your model was being served, at least as a single unit. We can talk about the horizontal scaling part separately. That's a whole different topic. And so we did well when it comes to easy things being easy. I think we struggled with the hard things being possible in the early days. Example of hard things are cases where we're seeing where more and more our customers have their own custom models that sometimes they've fine-tuned, sometimes they've pre-trained. We now have 6 or 7 foundation model companies as customers who are sophisticated enough to pre-train their own models, and they're trusting us with the inference layer. That's not a situation of, hey, here's 2 functions, good luck. Have to have much deeper integrations with them. And so that's where we started rethinking some of the abstractions of trust over time to allow for those custom use cases. And that has been successful. Another place where we didn't think about at first, but became important, was seeing more and more use cases where the customer was saying, I can serve my models on Baseten using Trust, fine, but my use case is not just call the model, get the response, and run with it. I actually have a multi-step inference workload. So an example of that is the company Bland AI with their AI phone calls. To make an AI phone call happen, you need to transcribe what the human said, a couple of LLM calls to figure out what to say back, and then text-to-speech to actually have the end-to-end workflow working. Now, you can have these be 3 separate models, 3 separate deployments, but think about what happens is that you have to call the first model, wait for the response, call the second model, wait for the response. All of that network back and forth is killing you. The latency is becoming too high. That's not something that we had designed for initially. And so that's when we came out with Trust Chains, which is the DevX for building these multi-step, multi-model inference workloads, but doing so in a very low latency way. So that instead of you orchestrating all of these calls and incurring all of that network latency, you're actually making one call, and these models are actually talking to each other. They run independently on their own hardware, with their own auto-scaling behavior, but the data from one to the next step is being actually streamed. And that way, going back to the AI phone call use case, you can get sub 400 millisecond latency AI phone calls that actually feel very realistic.
And those are all models hosted on Baseten, or do you also do chains?
Those have to be models hosted on Baseten. If one of those steps is not hosted on Baseten, then you're still incurring a massive latency on the network side.
Yeah, and then just to maybe tie this into SGLang, how do you kind of think about the hidden magic, Should people know that you use SGLang? Like, should people care? Like, especially for the people building the models, Like, does it matter to them that you use a certain model runtime, or do they not care? Everything just goes through the Baseten platform the same?
Yeah. Should we talk about it? Yes, 100%. We want to be the transparent provider. I don't want to say, oh, just give us your model and voila, magic, and trust our magic. I want that magic to be very transparent to our customers. That has worked really well for us. And you really need that, especially when you're onboarding, foundation model companies. And, they're not going to, just turn a blind eye on how things are run underneath the hood. When it comes to customers caring about what's happening underneath, they do, but more than caring about this framework versus that, they care about how the final output. In other words, is the quality the same, or somehow something has changed underneath the hood and the model isn't actually producing the same quality? How is the latency? And especially for certain use cases, what is the time to first token? And is that sustained? What is the P95 of that? What is the P99 of that? How well does it handle throughput? When you start getting a massive burst of traffic, does it still sustain those P95s and P99s? How do I make sure that the security of the data being sent into the model is guaranteed? How do I make sure compliance is guaranteed for HIPAA use cases? And how do I make sure that the data remains within a certain geo for compliance reasons or for latency reasons? And so those are the concerns that the customers are coming to us with. Less so about, hey, here's my model, make sure you run it with TRTLM, or make sure you run it with SGLang. Yep.
Can you maybe give us an overview of all the different frameworks that people may use? So you have SGLang, TRTLM, VLLM. Those are kind of like maybe the open source research ones. And then some of the other commercial companies are building some of their own stuff. But what's the state of the art today? Maybe like the top 3 most popular, and then we can talk about why SGLang came to be and what makes it different and some of the performance boosts that you get.
Okay, yeah. I think for the common use case, maybe not the DeepSeek V3, for the common use case, I think SGLang's performance is better than VLM, and its usability is better than TensorRT-LM. So when user care about the performance and the usability I think they will choose SGLang. And for the DeepSeek V3 case, because we do a lot of optimization in SGLang, something like DeepSeek V2, they proposed attention variant named MLA, multi-latent attention. And I think SGLang is the only framework supported that. Maybe LightLM and TRTM also support, but VLM doesn't support. And also in DeepSeek, in the SGLang version 0.4, we also support the DP attention for DeepSeek. And in the latest SGLang release, we also support the blockwise FP8 kernel. And that kernel was adopted and copied by VLM later. So I think we have done a lot of optimization for DeepSeek. That's why SGLang is the recommended LLM engine by the DeepSeek team.
And maybe one thing to point out, and I think this is important, is that the framework that you choose is part of the equation for running mission-critical inference workloads, but it's only a part of it. So maybe I can draw this out just based on the experience, based on what I've seen in the market, as to what it takes to run mission-critical inference workloads in production. I think it takes 3 things, and each of them individually is necessary but not sufficient. One is performance at the model level. So in this case, how fast are you running this one model running on a single GPU, let's say? The framework that you use there can matter. The techniques that you use there can matter. The MLA technique, for example, that Yineng mentioned, or the CUDA kernels that are being used. But there's also techniques being used at a higher level, things like speculative decoding with draft models or with Medusa heads. And these are implemented in the different frameworks, or you can even implement it yourself, but they're not necessarily tied to a single framework. But using speculative decoding gives you massive upside when it comes to being able to handle high throughput. But that's not enough. invariably that one model running on a single GPU, let's say, is going to get too much traffic that it cannot handle. And at that point, you need to horizontally scale it. That's not an ML problem. That's not a PyTorch problem. That's an infrastructure problem. How quickly do you go from a single replica of that model to 5 to 10 to 100? And so that's the second pillar that is necessary for running these mission critical inference workloads. And what does it take to do that? It takes, some people are like, oh, you just need Kubernetes, and Kubernetes has an autoscaler, and that just works. That doesn't work for these kinds of mission critical inference workloads. And you end up catching yourself wanting to bit by bit rebuild those infrastructure pieces from scratch. This has been our experience. And then going even a layer beyond that, Kubernetes runs in a single cluster. It's a single cluster. It's a single region tied to a single region. And when it comes to inference workloads and needing GPUs, more and more, we're seeing this, that you cannot meet the demand inside of a single region. A single cloud's single region. In other words, a single model might want to horizontally scale up to 200 replicas, each of which is, let's say, 2 H100s or 4 H100s, or even a full node. You run into limits of the capacity inside of that one region. And what we had to build to get around that was the ability to have a single model have replicas across different regions. So, there are models on Baseten today that have 50 replicas in GCP East and 80 replicas in AWS West and Oracle in London, etc. And that was a big investment that we had to make. The final one is wrapping the power of the first two pillars in a very good developer experience. To be able to afford certain workflows like the ones that I mentioned around, multi-step, multi-model inference workloads. Because more and more we're seeing that the market is moving towards those, that the needs are generally in these sort of more complex workflows. So these are the three pillars that it takes to run mission critical inference workloads. And the choice of the framework, the serving framework, is really a part of the first pillar. And that's something that I'm seeing in the market, that like people who are somewhat new to it, they're like, well, VLM equals production. That's what it takes to run inference workloads. And that's, in practice, that is not true. And I wanted to call that out.
I agree with Amir, because I think it's open source libraries such as VLM, SGLang, LightLM, or TensorRT-M. They only provide a library. They don't provide a product solution.
Yeah, can we maybe talk about some of the SGLang unique things? So I read through the paper. Sounds like some of the main use cases, like when you have very large batches, which makes sense for your use case, and also kind of longer context. What was the decision behind creating the framework, which I think is like around 1 year old? I think the paper came out December 2023, something like that. So it's still still fairly new compared to some of the other ones. And then maybe what were some things that you had to change, as you built it, or any fun stories?
Yeah. I think last year, not last year, sorry. At 2023, maybe August. At that time, Lianmin and Yin want to create the SGLang maybe for the front end, something like LLM program. They want to solve that problem. And at 2024, January, they support something like Radix Cache. It's a prefix caching technology. I think SGLang is the first framework that support prefix cache. And at February, they also support constraint decoding and support some jump forward. So at that time, it's a no for the language generator, not the inference backend. And at 2024, July or June or July, we want to make SGLang a fully functionality LM inference engine. It's just equivalent with the VLM or with the TensorRT LM. So at that time, we published a blog compared with other frameworks, and its performance is amazing. Yeah, at that time, I think its performance is maybe its throughput is 3 times than VLM. So after that, VLM also do some refactor to make it faster. And at September and December, we continue to release new versions for SGLang. Yeah, we support some DeepSeek optimization such as MLA, optimization, DP attention optimization, and we also support the serial overhead CPU schedule. Also, we support something like SGLang router for the cache-aware load balance. Yeah, we deliver so many features. We just build and ship. And I think why Lianming and Yin want to create a new framework rather than use the existing solutions such as FearM or TensorRT, because at that time, maybe for the FearM, I think it's easy to use, but its performance maybe it's not good. Some design, I think it's not okay. Yeah, maybe the code is a little messy, and if you want to extend some new feature on top of that, it's a little hard. And TensorRT, I think it's blazing fast. Its performance is so good, but it's not easy to do some secondary development. If you want to add some new feature, it's a little hard. So just think about, how can we create a new framework? It can achieve the good performance. Also, it's easy to develop, to maintain. So that's why they create the SGLang project.
Let's run through maybe the three main techniques behind SGLang. So the first one is Radix Attention, which focuses on KV cache. And when you think about a model that is, as large as DeepSeek V3, especially, like having better KV cache reutilization is great. Can you just talk a bit about that performance impact?
Radix cache, I think it's the technology of the prefix caching. And it's a special case for something like block size is 1. For FearM or for other frameworks, they use something block size 32, and SGLang use the block size 1. I think if you use the block size 1, you can make the cache hit rate higher than other frameworks. I think that's the mainly benefits.
And for your case specifically, how does that change when you have like a Baseten type use case where you do not have a share endpoint versus is this less helpful for GPU clouds to do one model for many people that have very different use cases versus when you have just one endpoint for one customer? I'm sure they have a system prompt that a lot of models share and things like that. Anything you want to mention there?
Yeah, we've seen this be massively helpful for the reason that you mentioned. There is a certain sort of finite number of prompts, or at least prompt prefixes that are being used per customer. And what we've seen is that prefix caching and the different techniques to make that better has been massively helpful. However, we still had to build on top of that. The example there is that you have a model with dozens of replicas, each of which has its own state of KV cache. A new request comes in, and what we used to do back in the day was that that request would be randomly assigned to one of these replicas. But the better way to do it is that knowing the state of KV cache in these different replicas, trying to decide which one it should go to. One of the parameters that you need to consider, there are other parameters to consider around the size of the queue at each of the replicas and the location of each replicas, depending on how geo-aware you want to be. But adding that additional consideration around KV cache aware load balancing was something that we saw improve latency quite a bit for our customers.
And then the second part, which was maybe the harder one to understand as a practitioner, which is this idea of turning some of the decoding process into a finite state machine instead of a more open-ended, when you're using, especially for structure outputs. Can you maybe explain what that means? And I would love to learn too. So maybe this is an opportunity for everybody to better understand how you think about going from a normal kind of token by token decoding to having a more, I wouldn't say pre-compiled, but pre-understanding of what the paths are going to be.
I think SGLang support constrained decoding, and it also support jump forward. And we use something like outline or the X grammar to do change the convert the schema from JSON to the FSM, the state machine. And we can use the state machine to control the output, something like the output maybe to the JSON mode or something it should be obey some rule. So in that case, because the output should obey some rule, so you can skip some token something like you should decode 4 times, but you should obey that rule. Or you can get that token in advance. You can just use one preview to replace the 4 decoding, for example. So that's why you can jump forward.
I guess the question is like, why doesn't everybody do that? When I was reading, I was like, this just sounds better, especially both for accuracy. You're kind of constraining for structure output as well. You can do faster decoding. Are there downsides to it as well?
I think maintain jump forward is a little hard. Yeah. At later, we support something like CPU overlap. I think in the overlap model, we even make it compatible with the jump forwarding, because just if you want to maintain the jump forward with other features, it will be more complicated. So I think we only use it for setting. We disable it by default. But if you want to enable it, you can just use some arguments to enable that. But it's a little hard to maintain, especially compatible with other optimization features.
Just as a side note, you mentioned Xgrammar, which I had never heard of about, and I looked up the GitHub repo. It's actually from MLC, which we talked to TQ. I think a while ago. Any comparisons between Xgrammar and outlines? Is there a trend in this world, or is it mostly settled science?
To be honest, I prefer Xgrammar.
Okay, tell us more.
MLC AI is founded by TenCent. Both TenCent and the Xgrammar's author Yixing Dong, they were the students graduated from Shanghai Jiaotong University. And the creator of SGLang, Lianming and Yin, they also graduated from Shanghai Jiaotong University.
Oh my God. Is it the Berkeley of China?
Yeah, you're right. And I think Xgrammar's performance is better than the outlines. And also in the TensorRT-LM, the latest release, TensorRT-LM also integrate Xgrammar as the backend for the constraint decoding.
Okay, this is new to us. We had Remy from Outlines speak at my past conference, but I did not I wasn't even aware of Xgrammar being a thing. But yeah, I mean, structured output is something that a lot of people care about. We had OpenAI talked about their structured output implementation, and there's a lot of interest in making sure that there are no trade-offs. I think there's a little bit of FUD around how maybe the models are dumber when you use structured output instead of the sort of base sort of next token generation, but I don't think it's significant that much.
Yeah.
We can talk about the last one, which I don't know if it's as relevant for base 10, which is the third technique of SGLang, which is API speculative execution, which seems to be only for API-only models.
Oh, yeah. I think it's the front-end feature. It's not the back-end. Yeah, something like you have some control flow for the LM task. Yeah, such as you have the one request to get a result, and you just continue to another call. And for this case, you can use the SGLang front-end language to describe the control flow. It will make it easier to control that pattern.
Okay, awesome. Tracing this human path, I'm pretty sure I know the answer, but is there a reason like big projects like Grok, like XAI also use SGLang?
Yeah, right.
Is it just the same people?
Yeah, right. Lianming and Yin are the XAI's member of technical staff.
I mean, it makes sense. I wonder if it, what's the impetus for SGLang to kind of break containment? It seems like VLM obviously has it's 1 year older. It has more community pull. I wonder how this will shake out. I don't really know. But, you said it's a library. You said VLM's library of SGLang is much more comprehensive. I mean, do people care? Maybe it's like when you're serving models at scale, then you start really prioritizing the sort of performance that SGLang offers.
I think if you care about the performance, maybe TensorRT is the best solution for now, especially for the latency sensitive scenery. TensorRT doing well. But if you also want to implement some feature by yourself or do some optimization by yourself, you want to customize the framework, I think SGLang is a good option. And VLM, I think VLM's community support is very nice because it was used by so many users and it has so many GitHub stars. And SGLang, when I participated in the SGLang team at July, it has only 2,000 stars. And right now it has more than 7 stars. Yeah, I think it also grows so fast.
Anything that people should look forward to that's on the roadmap for SGLang that people should be aware about?
Yeah. And we post the roadmap in the issue, and we pin that issue. Also, we have bi-weekly meeting to sync with the community about our progress, our plan, which feature do we want to implement in this quarter, something like that. And we also co-host some meetups, something like the first meetup we co-host with the MLCLM and Flash Info. And we also participate in some hackathon, something like Camo AI hackathon. We do the presentation about SGLang. Yeah.
I just saw it now. It sounds like actually there's, we mentioned Eagle, mentioned Medusa. I think Amir mentioned Medusa, but Eagle is also part of that cabal, the speculative decoding techniques. It looks like not yet supported.
Yeah, we already support it. And I think in the open source implementation, something like VIM, SGLang, and other frameworks, I think it's the SOTA performance. And currently, even use the TenCent RTM, it only supports Eagle 1, not Eagle 2. Yeah.
And one thing to note about speculative decoding, different versions of it, is that the framework supporting it is one thing, but you will have to do the job of the training of the draft models or the additional heads. And a lot of the benefits will come from how good you are at the training aspect, in terms of the data that you use to train the draft model, to essentially distill the target model or mimic its behavior so that you can have a very high rate of acceptance. It's the kind of throughput improvement that you get are ultimately dependent on how good of a job you do at training the draft model in the case of the draft target model mechanism. So that's another thing that's like, hey, does the framework support it? Or you can just turn on speculative decoding with a flag. That's not the case. There's more that goes to it.
One more side thing on training. I also noticed that with OpenAI offering fine-tuning for O1 and all these things, I think people are also very interested in sort of RL trainers is what you have here. It looks like you're supporting Hugging Face TRL and Open RLHF. Do you think that this will become something that a lot of people are demanding, like the sort of general feel of RL for LLMs relatively abandons, I think, up till like the end of last year, basically?
Yeah, I think so.
I don't know. It's like, it's one of those things where like maybe people have to wait for a base model that has some layer looping or some other sort of friendly architecture for reasoning instead of just pure RL on LLMs. Because I think so far people have not really exploited RLHF as much in the wild. I mean, correct me if I'm wrong.
Yeah, so I can give you some examples of when we've seen it work. Again, this is generally done by our customers before they come to us for inference. But there's examples like in the healthcare world, fine-tuning models for understanding medical jargon, like for Whisper, for instance, a version of Whisper that I can actually understand medical jargon. So that's the non-LLM use case. In the LLM use case, staying in the healthcare space, models that can do medical document extractions and do a very good job compared to even, state of the arts, because of the data that the company had gathered through human in the loop. Are those going to go away? The need for those are going to go away because there's a model that can do reasoning and do a very good job at it? I don't know. My intuition says yes. Will it be cost effective? That's the question that I have. And in the short term, no. In the long term, maybe. But I haven't seen the need for the more traditional fine-tuning actually go down. In fact, we see that quite a bit right now in the market. The question for us is, hey, do we want to address that market knowing that the entire market might go away one day? And my general answer to that is, let's solve today's problems. Even if they're not around in 2 years, you will learn a lot along the way by onboarding customers that have today's problems, and you learn from them about tomorrow's problems, and you will build ahead for them.
So hang on. Why do you think fine-tuning might go away?
Because, like you said, there's going to be models with complex reasoning capabilities that can actually figure it out in a, few shot kind of way without needing a large data set to fine tune the model with. That's what some people are saying.
I really have a trouble believing that'll be the case. Much more believe that it's just easier to change your prompts rather than actually do full fine tunes or even parameter efficient fine tunes.
For sure.
Is there anything else that we haven't touched on that you wish the people ask you more about, because it is something that is very interesting from your point of view of like what you're seeing among your community?
Yeah. When we released the DeepSeek V3 support, we have some community user, something like Cursor. Do you know Cursor? I think it's very popular.
Of course. I use them every day. When I type code dot inside of my IDE, my terminal, it actually opens Cursor instead of VS Code. I feel very bad for VS Code.
And when we released the DeepSeek V3 support, some employee from the Cursor team also very interested in our implementation and reach out and ask some question from us. So I think as SGLang grows faster and the features optimization, we iterate so fast. And I think there will be more users from different companies, from different teams to use it.
Honestly, I would go back to what I emphasized earlier, which was that I wish more people asked about what it takes to run mission critical inference workloads. Because I see this in the market sometimes that they're like, well, I can just use VLLM and that puts my model behind an API and that is production. But really it takes 3 pillars that all need to be there. One is performance at the model level. That is where frameworks that we talked about today really help you with, but you still have to guide them. Like when it comes to speculative decoding, yes, they support it, but who's going to train or fine tune the draft model or the Medusa heads? Or who's going to ensure that the reliability of the VLM server, that you see it in production, like there are crashes. How do you recover from those without affecting production traffic? But by itself, that's not enough because invariably that one model running on a set of hardware is going to get too much traffic that it cannot handle, and at that point you need to horizontally scale it, and that's not an ML problem. That's not a PyTorch problem. That is an infrastructure problem to ensure that you can horizontally scale up your model extremely fast to meet your, P90, P99 latency requirements, and to ensure that you're not running out of capacity in a single region that model lives. You end up having to scale that model across different regions and across different clouds even, to ensure that model is not being starved of resources in the one place that it lives. So that's an area of investment that we started investing in some time ago and really paid off this past year. And the third pillar is enablement of workflows such as the sort of AI phone call example that I told you about, the ones that require multi-step, multi-model inference, but in a very low latency way. That's the third pillar that really allows the developers to be able to use the power of the first 2 pillars and then be able to combine them when especially you need multiple models for your workflows, and doing so in a reliable way, repeatable way, and a low latency way. And that is, those are the 3 pillars, honestly, that we have been investing a lot on. Some of which we started investing in 3 years ago and it really started paying off a year ago. So it takes quite a bit of build to get it to the point where you're truly running customers' mission critical inference workloads. What do I mean by mission critical inference workloads? Inference where if inference is slow or down, the main product of our customer is slow or down. So they really care about it. They have strict requirements around latency, around being able to support large throughput, about being able to do so in a way that other customers' usage doesn't affect the SLAs that they are getting and dealing with noisy neighbor problems. And inference done in a compliance way, whether it's HIPAA or certain SOC requirements. And also inference done in a geo-aware kind of way, both for compliance reasons and also for latency reasons, where you forward the traffic has an impact on latency in situations where 50 milliseconds really matter, 100 milliseconds really matter. And we're seeing more and more of those use cases.
Well, one way I would recommend doing that is kind of a manifesto type of thing. I'm sure you know Heroku's 12-factor app.
I've seen that. Yes. That's a good idea, actually.
Yeah. Maybe even put on a separate property than base 10 and just go like, here's what we think, mission critical AI application should be, and, have some thought leadership there and flesh it out and, see if the market takes it on as a mission. And obviously you will be best prepared to serve that market as well. I've also seen this done very well with enterpriseready.io. I think it used to be done by, I think it was called Gravitational or Replicated, one of those.
From Replicated.
Yeah. These kinds of things, when you have a list of requirements, when like you're like, look, everybody needs this. Okay, like write them up and then, put a little bit of marketing on it, split it out from the main company brand. That tends to work very well.
Yeah, good idea.
Cool. Well, thanks so much for your time. I think this is a really good dive into both Baseten and SGLang and a little bit of DeepSeek V3, which people are very interested in. I'm trying to talk to them as well because obviously they're a fascinating lab, and but I think you guys are doing a lot to make it accessible for everyone. So thank you so much.
And just to give Baseten some street cred, they were one of the first sponsors for Latent Space events, and Amir brought 100 croissants at our Latent Space Hackathon in 2023. So just want to bring that up. I saw Phil and at AWS reInvent, and I told them that was one of the first events that we really did, and one of the turning points of this industry as far as community goes, in my mind. Everybody was there.
The croissants.
No, not the croissants. the event itself.
Yeah, entire companies launched.
Yeah, you were. I mean, Nader from Brev was there and did with Joseph from RoboFlow. They did like the prompt battle thing. Like Harrison was a judge, and it's like Jerry from Index was there. Like kind of like everybody that is kind of now breaking out. If you look at the graph that Jensen put on the screen at CES with some of the companies they work with, a lot of them were at that event. So yeah, thanks for staying involved with us, Amir, and I'm sure we'll do more together. And thank you guys.
Many more years to come, for sure.
Thank you for taking the time today.
Good to see you both, Alessio, Sean.